Yeah, sorry, I spazzed again. Michael saved my bacon here. We just read off the answers to the assignment 3C. It was 1 through 13 odd. Number one, I'll just do it on the board. Why not? Number one should look like this. It's a line with a slope of 1 going through 0, 0. Wow. And shaded up. Okay. The second one should be x-intercept of 4, open dot, y-intercept of 3, open dot, dotted line, and if we test 0, 0, it comes up true, so you shade toward that. This is number 5. This is a parabola. It didn't move, or it didn't flip, or it didn't get any taller, so it starts at 0, 0, over 1 up 1, over 2 up 4. It's a solid border because it's equals. And it's y is less than, so you shade below. Does that make sense? So far? All right, I think I've got everything up. Number 7 is is kind of an annoying one. Let me do this over here. Y is less than 2 minus 1, 1. 2x squared plus negative 4x plus 1. How do you graph this thing? Well, it's a parabola, but it's not in vertex form. There are 2 tricks we learned on this. One is, do you remember the negative b over 2a trick for finding the axis of symmetry? That's one way. Here's one way to do it. So method 1. You don't have to do both methods. You just pick whichever method you want. Oh, that's right. So a is equal to 2. B is equal to negative 4, and C is equal to 1. When we're talking about y, just pretend it's equals for a second. Ax squared plus bx plus c. If it's in this form, which is called standard form, standard parabola form, then these, what do you call it? The axis of symmetry is x equals negative b over 2a. Let me know when that's from. Where do you find it?
Quadratic formula?
Yeah, it's the first half of the quadratic formula. So, in this particular case, it's negative 4 over 2 times 2. So 4 over 4, or 1. So the axis is x equals 1. Which is nice, but I don't have everything I need to find the vertex. This is kind of a cheap way to say it, but it's the axis, comma, plug in the axis. The axis is how far over the vertex is. So then just plug that in, that's x. So we know this is 1 comma something. How do you get to something? Plug 1 in here. So it's going to be 2 times 1 squared plus negative 4 times 1 plus 1. Do the exponents first, so 1 squared is 1. 2 times 1 is 2, plus negative 4, plus 1. This is negative 2, plus 1 is negative 1. We now have a vertex. Note, open dots. So 1 comma negative 1, put an open dot there. Can you tell me what pattern I would use on this? What's the normal pattern of a parabola? What's the normal one? By the way, you're actually ahead of me, but yeah. Over 1, up 1, over 2 up, for parabola. Over 2 up.
Over 2 up, oh my gosh, I can't.
Here's the hint.
Over 2 up, 2.
Squared.
4.
4. Over 3 up.
9.
9. Over 4 up.
16.
Etc. So what's this thing doing?
Is it doubling it?
Right. This is the height multiplier, which means it's twice as tall. Instead of over 1 up 1, it's over 1 up 2. And over 2 is normally up 4, but this time it's up what? 8. Correct. 1, 2, 3. So 1, 2, 3, 4, 5, 6, 7, 8. Yeah. So right here, you have a dot here and a dot here. It should be a dotted parabola. So there's your actual parabola. Find the vertex, and then find the height multiplier. That'll give you your accurate parabola. Where do you shade? Julie, no. If y is less than.
You shade for something to come up with a point.
You could. That's the guaranteed way to do it.
I guess what we learned is to shade down.
Exactly. If y is by itself, you can just follow the sign. So if y is less than, you're pointing down. So you shade underneath this thing. If y had been greater than, you would have shaded up and inside it. Does that make sense?
Wait, what number is that?
I forgot to write that. It's number 7.
Oh,
It is number 7.
Got it.
Yep. Everybody good so far? 1, 3, 5, 7? Then you're at the other ones. We went up to 13, correct?
Yep.
Okay. Number 9. This is, there is a trick to this. It's actually easier than you might think. Again, once you know the trick. Before you know the trick, it's a little annoying. 0 less than or equal to x less than or equal to 2. Can somebody tell me what values of x we're looking at here? What values, John?
Between 0 and 2.
Between 0 and 2. Including them or not including them?
Including them.
Right. On a number line, what we would do is put a solid dot at 0, solid dot at 2, and shade in between. If x is in between, you shade in between. So on all numbers between 0 and 2 covered. On a graph, you do the exact same thing, only instead of a dot, you do an entire solid line. And then over a 2, you do another solid line. And you shade in between them. Does that make sense? You could do it the long way. You could split this up. This is x is less than or equal to 2. And if you read this backwards, if 0 is less than x, that means that x is greater than 0. If you graph both of these at the same time, this will shade to the right, this will shade to the left, and this is where they overlap. So you get the exact same thing with a little bit more work. Okay? And if you test a point like 3, 0, it'll come up false. So you shade it in between. Okay. Number 11. Absolute value of y is greater than 1. So this is number 9. I would recommend splitting this. There is a way to do it without splitting, and I'll show you in a minute. But, split. Now remember, splitting flips the sign on the negative side. So this is regular y is greater than 1. This is y is less than negative 1. I want to graph these on the same graph. Go up to a height of 1. Now it's an open dot with an open line. This is the line y equals 1. I'm doing y as greater than 1. So which way would I shade there? Okay. Jack. Which way would I shade?
That's to the right.
If it were x, yes.
Oh, then it's
What if
not.
y is bigger?
Oh, that's off.
Exactly. Shade up. Does that make sense? Now down here, go down to negative 1. Dotted line. I should put arrows. And Holly, which way would this shade?
Down.
It would shade down. So you're basically shading everything not in between the two lines. So you shade above the top one and below the bottom one. So you have this sort of gap of 2 inches wide all the way across. Number 13, last one. Absolute value of x minus 3 is less than 2. Let's try it. This is number 13. X minus 3, less than 2. Again, I would split this. You can't solve it just yet, or you can't graph it yet until you solve it. We've got x minus 3 is less than positive 2, and x minus 3 is greater than negative 2. That's how you split. So, get x by itself, it should be a little, by the way, when you add 3, it does not flip the sign. X is less than 5. And the other one, if you add 3, x is greater than 1. So in this one, if you go over to 1 and 5, again, x is 1 is not just a dot. It's an entire line. It'll be a dotted line. And then over to 5. My question is, it's either going to be shaded in between or outside. So, no. How do you tell which way to shade?
Well, you can kind of just look at the X plus 5 and X.
Okay. So which way is this shading?
That shades to the left.
To the left?
And then you don't really need the other one since you know it's going to shade in.
Correct. But this will confirm it and shade in between. Does that make sense? In most of it, when they give you an absolute value, I would suggest there are ways to do it without splitting, but splitting is pretty much the guaranteed way to find out where things are. Okay. I promised you a shortcut on the absolute value ones, partially because this is going to come in handy on the next homework, and partially just because I promised. Take out your notes. Quick example. Suppose I give you the absolute value of x is less than or equal to 2. Can somebody refresh my memory of the definition? Like, what does absolute value mean?
Isn't it like how many spaces away from 0 on the number line there?
Exactly. It's how far away you are from 0. Can somebody translate this into English then? So, the absolute value of x means how far x is away from 0. How far is x away from 0?
2 spaces?
2
Less
spaces
than
or
equal to?
or less. So basically, it covers all the numbers that are 2 spaces away from 0 or less. Let me show you what a number line looks like on this. Here's 0. I want to go 2 spaces away from 0 on either direction. If I want to cover all of these points that are 2 spaces away from 0 or less, there it is. Does that make sense? So it's all the distances that are 2 spaces away from 0 or closer. On a graph, it looks kind of the same. Just you have a solid line, and you shade in between. Does that make sense? It's a lot like what we did here. This isn't quite the same, but it looks a little like it. Can somebody do this? Absolute value of y is less than 5. Tell me what that means in English, Sophie.
Do you have some splitting?
That's how you normally do it. Put this in English for me. What does absolute value mean again?
Y is 5 spaces away from 0.
Yeah, actually it's
Negative 5?
not negative, but y is not exactly 5 spaces from 0, but it's
Oh, it's less than
less than 5 spaces away from 0. So would you say that all the y's we want are closer to 0 than 5 or farther away? Closer, right. In other words, all the stuff that's closer than 5. If I did this in real life and I said, okay, everybody go jump in their car and drive, but I want you to restrict yourself to this, where y is like north-south. How far could you drive before you have to stop? Like, how far north or how far south could you drive before I order you to stop? Yeah. What? 4.9999, yeah, basically up to 5, but not hitting it. Does that make sense? This doesn't care how far left or right you go, or east or west. But as far as y, the north-south, you can't go any further than 5 miles away, a little less than 5 miles away, or to the south, a little less than 5 miles away. Does that make sense? So here's the graph, if you want to just do it in one step. If you go up to 5, dotted line, go down to -5, dotted line, and you shade in between. That's the fair legal place to go. Does that make sense? This is something of a shortcut where we see absolute value of something is greater than or less than or whatever. You can think in your head, absolute value means how far it is away from 0. Let me try another one. I want to see if you can do both of these at the same time. I would like you to graph the following. Absolute value of x is less than or equal to 3. Y, absolute value, is less than 1. Graph it. What do you think? I'm waiting for volunteers. Michael?
Good job, Mom.
Wait, I'm sorry, so what are we doing? We're just grabbing?
We're graphing.
Okay, great.
In other words, we're kind of doing this, but I'm doing both of them at the same time. It's kind of like I just gave you instructions. Think of X as like east-west on a map, and Y as north-south on a map. How far east-west can you go? 3 miles. Can you go exactly 3 miles? Yes. They'll allow you to go to exactly 3 miles, but no more. How far can you go north-south?
Up to 1 and not 1.
Correct. A little less than 1 mile north, a little less than 1 mile south. Graph that for me. Tell me how to do it. Go.
So, go 3 spaces to the right,
Okay,
and 3 spaces to the left,
good. What do I put there?
and a dot.
Kind of, sort of.
What?
A little bit, kind of. Like, you can. Solid or open, by the way?
Solid.
Okay. That's just going to mark things. It's got to be bigger than a dot.
Yeah, but a line.
Sure. Nice. So solid line.
And then
Okay.
you go 1 down, 1 up.
1 down and 1 up. What kind of lines?
Open dot,
Yeah, open dot and what kind of lines?
dotted line.
Good. Where are you going to shade? Where's the legal region?
So,
Where is the legal driving zone, if you will?
I guess in that square.
Not quite a square, but
Oh, okay, a rectangle.
rectangle, yeah. I got you now. That's the solution. Making sense? So this is kind of giving you a zone where you can drive. Now, it's not always going to be a limited rectangle. Sometimes they're infinite, like this. It can go as far north or south as you want. It just says, don't go any further east-west than 2 miles. Let me try another one. Oh, let's see, how about this? I'm going to throw quite a few of these in here. Graph the following. Actually, I'll give it 3 of them. Let's see how big they are. Let's just say 2 less than or equal to x, which is less than or equal to 5. Absolute value of y is greater than 3. And y is greater than or equal to x. I want you to graph all 3 of those. When we're all done, we should have one shaded region, or, well, hopefully one shaded. So we should have 1 or more shaded regions that make this thing work.
Did you do random numbers?
Yeah, pretty much. The top one, can you tell me what that means? Think of the map. What does this say? Yeah,
Would it be like, you can go left to right, 5 and 2?
Sort of. Left, right that's a distance from 0. This is close. It's actually easier.
Well, I mean, like, okay, so would it be from 2 up 5? Like
Exactly.
5 miles?
On the right-hand side of the map, you can only go from 2 to 5, and you're limited to that. Does that make sense? So I'm going to do that. Would those be solid or dotted line?
Solid.
Solid. So go over to 2, solid line. I'll mark this 2. Go over to 5, solid line. And where do you think the shading would be so far? In between. Don't shade it yet. Use these little guide arrows. You might remember these from the corn and wheat problems. So why are we just doing guide arrows and not shading? Because if you shade, and then shade, and then shade, and you're trying to find out where they overlap, you might rip through your paper by the time you get done all that shading. I have done that, especially if you have like 5 or 6 of these. It's like, first of all, especially if you do the first one dark, then you gotta do the second one darker, and the third one darker, 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 and next thing you know, you're carving into the dash, so, which is bad. What does this mean? I'll take this one.
That y is greater than 3. So,
What are these?
oh, that it goes up to 3, no, up.
This is a little different than the last time. Here, it went up to 3, and over, basically 3 miles away from 0, no further. Remember, the absolute value means how far it is away from 0. Are we talking about how far left, right, or how far up, down here? Up, down. How far up, down do they want you to go?
3
3 or actually,
or more.
more. They want you to go more than 3 miles north and more than 3 miles south. So basically, if you're wandering around in here,
How does that work?
so it's kind of like you're sitting here and said, you've got like, or radio me when you're at your location. And you radio me and you're only a mile north. I said, what the heck are you doing a mile north? Keep driving north. I don't want you anywhere near us. I want to be 3 miles away, at least 3 miles away. Does that make sense? Actually, I don't even want you 3 miles away. I want you 3.1 or something. So does it make sense that you basically go more than 3 miles up, or what?
More than 3 miles down.
More than 3 miles down. They just want you to be 3 miles away, north or south, or more. Actually, just more.
This whole driving thing is really confusing.
Oh, good. It's actually kind of humorous because I've gotten lost one a few times in my life. Got lost the very first time I went on a date too, which is really kind of.
What's the date in your car?
Well, that made an awesome first impression.
Like super duper fast?
The drive was supposed to take an hour. It took 2.5.
Oh my gosh.
I ended up in like somebody's, like a farmhouse, a huge driveway. It was like a mile driveway. I didn't know it was a dead end until I was like, okay, there's like a pig farm.
Did she think you stood her up?
This stinks. No, she was in the car with me.
Oh.
We were supposed to be going to like dinner and a movie, and we missed the movie. Not
Was she
so
fine about
appropriate.
it?
What's that?
Was she mean about it? Was she cool?
No, she was actually pretty good about it. She went out with me again. Anyway, she was very nice about it. But anyway, that was, we got back and it was the homecoming dance. That's right. We did get back in time for that, but we had to like.
So this was in high school?
We had to grab fast food on the way back from wherever I got lost. So, yeah, that was awful. Where am I gonna shade? Am I gonna shade inside or outside? Good. Outside, yeah. I wanna go further than 3 miles away. So shade. Does that make sense, Omar? Can anybody see visually what zones are still in the running? What zones are still legal? Keep in mind, I want to be in between these two vertical ones, but I want to be outside of these. There are 2 zones that are still good. This belt down here, not this. And this belt up here, that's all that's still in the running. And one last thing, how do you graph that? That was actually in the homework, sort of. Yeah,
Well, it's like slope-intercept form. So
Yeah.
it's really 1x plus 0.
correct. Go for it.
Or
Here's 0, 0.
yeah, and
So
so
what
you
do I
just
get?
go up 1, over 1.
What kind of a dash?
Really close.
Close, good. And then up 1,
Over 1.
over 1. Up 1, over 1. Up 1, over 1. Up 1, over 1. Up 1, over 1. You did it. So, solid line. Which way do I shade? How do you tell?
Oh, sorry, me?
Yeah, please.
Oh,
There's a shade.
up.
Good. If you have a letter by itself, you can follow the thingy. Does anybody see the zone that's the final region? Go.
It's, I don't know how to explain it.
Hard to describe.
It's just above and in between those 2 lines.
Correct. And does it include this little rectangle here?
No.
No, it does not. Here's what it looks like. It does go forever, but it does not go past that little boundary. Does that make sense? If you can do that, you can pretty much do any problem that the book's gonna throw you. I will, however, give you one last helpful hint. This may save you a lot of splitting. There's nothing wrong with splitting, of course. But, yikes, for your side. I want to show you, this is one we did earlier. Absolute value of x is less than or equal to 2 versus absolute value of x minus 3 is less than or equal to 2. Let me show you the difference. This we already did. This is, it says don't drive any further than 2 miles east or west. They don't say anything about why, so you can drive as far north or south as you want. And you can't go any further than 2 miles east west. You got to go in between those. Okay, so shading in between here. Everybody feel sort of comfy on that? What about this? I would like you to split this just once, and then we'll see the shortcut. Can somebody split this for me?
X minus 3 is less than or equal to 2.
2.
And then x minus 3 is greater than or equal to negative.
Good. Somebody solve this one. And
Add 3 both.
add 3 both sides. Does that flip the sign?
No.
No. So x is less than or equal to 5. And try this one. Is this the exact same one we did?
Very similar.
Looking familiar. Okay, so x is greater than or equal to
1.
1.
It might be the same.
So it's going to go from what? I forgot. My brain has a tendency to do the exact same problems over and over and over, which gets me in trouble. Because I sometimes do test questions on the board without knowing it. Solid or open lines?
Solid.
Solid. And this is solid. Do you think we shade in between or outside?
In between.
In between. It's bigger than 1, less than 5. Is there any similarity between these two graphs at all? I'll give you a little hint. Everybody see that the central line is like 0 on this one? What's the central line here? 3. Did they look similar now? They both allow you to go 2 miles left, right, but they start in a different spot. How far over did we start? Is there anything in here that might have told you that? Do you remember when we talked about inputs and outputs? Input does the opposite of what you expect. And then add and subtract is a move. Guess what minus 3 in the input does? Yeah.
Move the 3.
It moves the 3 spaces. We normally expect minus 3 to move which way, left or right? Left. And then we know it's left or right because it's x. Does it actually go 3 spaces to the left? No. Why not?
Because it is the opposite of what you expect.
It's the input. It does the opposite of what you expect. It moved 3 to the right. It's this graph shifted 3 spaces to the right. So, why do I mention that? First of all, that is just darn neat. Second of all, please open your books to page 107.
Are we done with the examples?
I think we are. By the way, I do have to royally repair the homework guide sheet. I don't know what happened, but it has no bearing on reality at all. I don't think it even goes that high. And it's not a 3A through 24A. It's like, what? There are no A's. So I think that got pasted from another class. That's the only thing I can think. But please change 3D. It is on page 107. If you just want to write it on paper, that's fine. Your assignment for tonight, 17 through 29 odd. 17 through 29 odd. Let me see. I want to offer one other correction. Skip number 23. Skip 23. That would be, 17 through 29 odd, but skip 23. That's it. They were trying to have you graph x cubed plus 4. We're not there yet. So, yeah, go ahead. So take a look at number 29. You see the intervals there? Absolute value of x minus 4. That basically means the graph got moved over 4 spaces to the right. That's all right. Now again, you could, I'll show you just once, like for number 20, I'll do half of 29 for you, just to show you if you get stuck. Splitting still works on this thing. You notice it's a three-sided inequality, like a triple inequality like this one. Everybody look up here for a second. You see this is like a triple inequality? These are triple inequalities. That means you can still do them. I'll show you at the top one. 1 is less than or equal to absolute value of the x minus 4. Yeah. And then less than or equal to 3. Here's how you would split it. This does not have 2 sides. It has 3. So you can do anything you want as long as you do it to, actually in this case, all 3 sides. Split it on the positive side. So this is going to be positive 1, positive 3. The positive side doesn't flip. It's going to be x minus 4. So with it. The negative side is going to be negative 1, negative 3, and these split. Make sense? Now solve. Again, you can do it as long as you do it to all 3 sides. I want x by itself. What do you do, old math people? One step should do it. How do you get rid of that? Yeah, you do not have to get rid of these. Add 4 to all 3 sides. It would be 5 less than or equal to x less than or equal to 7. Ta-da. That should be easy to graph. This one, add 4 to all these. There is one little detail I got to show you. 3 greater than or equal to x greater than or equal to 1, I think. They wrote this backwards. I would like you to fix it.
Why is it backwards?
We normally like them pointing to the left because we read from left to right.
Oh, so like lowest and.
Yeah, and I'd like to go from low to high. And this is going from high to low. Quick question, a quick example. If 7 is greater than t, what does that mean? What's another way to say that? If 7 is bigger than t, then t must be less than 7. Just read it backwards, like photonegative. Make sense? Do that trick here. Read from right to left. Pretend you're Hebrew for like 30 seconds. So, what do you get? Do a mirror image from right to left. Anyway.
1
1
is less than or equal
Equal
to
to.
x
Yes.
is less than or equal to 3.
Got it. Mazel tov. Congratulations. In Yiddish. So, questions? All you have to do is graph this and graph this on the same graphing space. If they overlap, shade the overlap. If they don't overlap, just shade. Okay, okay? Alrighty. The rest of the hour is yours. Go ahead and pound away at it. I will be around in case you get stuck.
So Mr. Kaufman, do you
Enjoy.
plan on celebrating your birthday on Monday?
Yeah.
I suppose.
Yay.
I'm trying to be bashful, and underneath the mask, it doesn't work very well. But, oh, and Julia, we're, bye, everybody. I'm waving here like that.
Hope
So,
you come back soon.
yeah, so, yeah, we're praying for you to come back soon. Take care, bye-bye.